Welcome everyone, and thanks to all of you who are joining us for the seminar today. So this is a seminar by the Australasian College of Road Safety, the New South Wales chapter. The seminar topic is Safer Vehicles, Opportunities to Reduce Road Trauma by Improving the Fleet. And we're lucky enough to have three wonderful presenters with us today. David Beck from Transport for New South Wales' Centre for Road Safety, Mark Terrell and James Hurnall from the Australasian New Car Assessment Program, or ANCAP. I'm Anna Chevalier. I'm the College New South Wales Chapter Seminar Coordinator, and I'll be facilitating today. And I have a couple of other people to thank too. I want to thank the members of the New South Wales Chapter Executive Committee who assisted with organising and promoting the webinar, and ARB for providing the GoToWebinar platform for us to use and for promoting the seminar. And we have three people from ARB joining us today, or actually it might be just two today, Isabella and Susie, who are helping to run the seminar and make sure it goes smoothly for us. We might have to go, that's a picture of Isabella and Susie. We might have to just go back one slide. Can we go back a couple? Wonderful, thanks Susie. I'm going to hand over to Duncan McRae. He is the New South Wales Chapter Chair, and he will talk a little bit about the college. Over to you, Duncan.
Hi, thanks, Anna. I'd like to welcome, as Anna just did, to everybody to our seminar here. A couple of things. I know that there's a mixture of college members and non-members out there, and I'd like to particularly welcome those non-members who are maybe joining us for the first time. Those of you who are unaware of what the college is about, I think it's pretty well encapsulated by the statement on the top of the slides. It says fostering communications, networking, professionalism, and advocacy in road safety. The college is very big on sharing information, collaboration, and working towards a reduction in road trauma through good networking and sharing of information. So that's why we run our seminar series. This seminar is one of a number that we've done this year in a range of topics, particularly interesting one because vehicle safety standards is an area that is moving incredibly quickly, and it's hard to keep up with the change, not just in the technologies, but the user interfaces, the legislation, the standards. Today's 5 stars, tomorrow's 3-star, and we need to understand that date stamps and the like have a play, and there's a whole bunch of information that we're going to learn about today, and we're going to have the opportunity to ask questions. I'll hand you back over to Anna, who can explain some of the logistics around that, but I'd just like to say again, thank you for attending and thank you for supporting the college in our seminar network, and we hope that you come to future seminars as well. So Anna, back to you.
Thanks very much, Duncan. I don't know if you worked in there, Duncan, that anyone who registered to attend also gets a 3-month free membership to the college if they'd like to take up the offer. So they get the offer, can take it up. And the college has a wonderful newsletter that they put out on a weekly basis. Apologies if I missed it and you'd already said all that. The presentation today was devised based on some requests from several of our attendees at previous seminars. So we often ask people to tell us if there's any particular topics they'd like. The topic today is, we might flick to the next slide actually, safer vehicles, opportunities to reduce road trauma by improving the fleet. And before they start, I'd like to introduce each of our presenters. So first up, we have David Beck. As the Manager, Safer Vehicles in Transport for New South Wales' Centre for Road Safety, David leads a team responsible for delivering projects, developing research and setting standards that improve the safety of vehicles and protective equipment, with the ultimate goal of delivering 0 fatalities and serious injuries on the New South Wales road network. The team has worked closely with Crash Lab and ANCAP to deliver Australia's first test facility for advanced driver assist systems, which has been in high demand since its launch in late 2019. David will be followed by Mark Terrell, Mark's an engineering graduate from the Australian National University. He's been the Chief Technical Officer at ANCAP since January 2017, following 21 years working for the Australian Government in the vehicle safety standards area. Mark has maintained a focus on active and passive safety systems and has been actively involved in the development of standards such as the recently introduced Global Technical Regulation for Pole Side Impact, and contributed to working groups on vehicle compatibility and side impact. Mark also has significant experience in vehicle regulation, including the reform of Australia's Motor Vehicle Standards Act and arrangements for the commercial importation of used vehicles. And Mark will be followed by James. So James Hurnall has a medical engineering degree and also a Masters of Business and Technology from the University of New South Wales. He has a lengthy career in vehicle safety and regulation, having worked as the Technical Director at the Australian Automobile Association, the Federal Chamber of Automotive Industry, Australia's Vehicle Industry National Association, and is currently the Policy Director at ANCAP, Australia's Independent Vehicle Safety Authority. Over the last few years, James has been actively involved with helping prepare Australia for the introduction of connected and automated vehicles. So together, David, Mark and James bring to our presentation a wealth of experience and information and expertise in vehicle safety, and we're really grateful to them for agreeing to speak to us today and the time that they've given us. As members of the audience, don't forget, have we gone through the, I think I missed something. Did we go through how to do a question? Thanks, Susie. Okay, so to ask a question, the audience is all on mute. To ask a question, if you go to that right-hand panel in your box, it's got a little orange arrow, you can pop it out by clicking on that orange arrow. Go down to where it says questions and you can put the arrow down and it will drop down. If you type into that box, you can send a question. It will come up with a little send box. You can send that and we will see that, and at the end we'll go through a question and answer time of about 10 to 15 minutes. Can we have the slide about the question and answers, like the housekeeping slide above this? So the webinar runs for about 60 minutes. The question time at the end is 10 to 15 minutes. The webinar will be recorded. The audience are on mute. After the webinar, a few days later, you'll be sent a link to a copy of the PDF of the slides and a copy of the webinar that you can watch online. So if anyone needs to leave early, that's an opportunity to come back and see the end. Okay, and can we flip across to slide 7, please? I'm going to pass over to David Beck, who's going to kick off the presentation. Thanks very much, David. Over to you.
All right, thanks, Anna. Yeah, as Anna said, I'm the acting manager of the Safer Vehicles team at Transport for New South Wales Centre for Road Safety. So just onto the next slide. And yeah, I'll be providing some background about the needs and latest advances in vehicle safety. So if we can move on. The important thing to note is obviously that vehicle safety improvements really have saved lives over time. So MUARC has done some research for us, and they found that without the most recent advances in vehicle safety, we would have been heading towards 450 deaths annually in New South Wales. And last year, it was just under 300 fatalities, which is still too many, but it is an indication of how far we've come already. And that is a combination of secondary vehicle safety, so improving crash protection, both for the occupants and in terms of aggressivity to other vulnerable road users and other road users, and also through advances in primary vehicle safety, such as electronic stability control and the more recent systems that we've had. So there's been over 600 lives that are projected to have been saved in the past 10 years alone from secondary vehicle safety, and a further 114 from primary vehicle safety. And we've gotten those advances through a combination of measures. Some vehicle safety measures have been mandated. I mentioned electronic stability control, that was mandated for vehicles starting in 2011, but also we're using other levers. So obviously ANCAP has a strong role to play in that, in informing the market, informing consumers and influencing the market. And also because we import our vehicles, we also do have benefits from advances that might be done overseas. But it's still important to keep in mind that the average age of the vehicle fleet is 10 years, which means that there's a lot of vehicles out there that could have lifespans of even 20 years. So any advances that we're having now, a lot of those benefits we won't see for years to come. And you can even see that from projections in reductions in fatalities over the years to come, which is estimated to be in the next decade. Just from the measures that we've had to date, we're expecting to have avoided almost 1,800 fatalities on the roads in New South Wales. Next slide. This is obviously a focus in the New South Wales Road Safety Plan. We're coming to the end of our 2021 plan, and we are putting in place measures at the moment for the next 5 years as well, with an aim to getting to 0 fatal and serious injuries by 2056. So some of the work that we've done recently, we have updated the vehicle procurement guidelines for New South Wales government fleet. So now there is a requirement that the vehicles do need to be 5-star ANCAP rated. And we also have some additional safety features. Most of these are now being addressed by ANCAP, but we also do require, for instance, reverse safety systems in there. We're also engaging with business, both with the heavy vehicle and the light vehicle industry, to encourage them to improve their fleet purchasing practices, with an aim that not only will that have benefits to them, but also it will have benefits further down the track when these become used cars that are bought. And also as more companies try and purchase safer vehicles, then the market will respond to that. And as Anna mentioned, we did launch in late 2019 a new test facility out in Cadell, which is near Orange in regional New South Wales. And that is the first of its kind in Australia to test these advanced driver assist systems to the ANCAP test protocol. So that's been heavily utilised not only by ANCAP, but by vehicle manufacturers as well, conducting their R&D. So it's just a way of smoothing the process for as much of these technologies to be introduced in Australia as possible. Onto the next slide. So talking about some of the safety features we have there, this shows some of the proportion of some of these safety features in the past 5 years in the registered fleet. So this is not just new vehicles entering the market, but all vehicles. So you'll see, even though ESC was mandated in 2011, in 2019, it still accounted for only 70% of vehicles registered in New South Wales, which is an indication of all those that didn't opt for ESC prior to the ADR being mandated, and they're still in the fleet. Now, that's an important one because it's been shown to reduce rollover crashes by over 30%. So there are a lot of crashes that have been avoided due to ESC being so widespread now, but a lot more could still be done. Another example is autonomous emergency braking, which can address a whole range of crashes, but for example, can halve the risk of rear-end crashes. And that's something which has grown in demand over time. Basically, it was just over 10% of the market of vehicles on the market that had it in 2015, and by 2019, more than half of the vehicles on the market had it. You can see it accounts now for over 10% of the market. That proportion will increase because, as many of you are probably aware, the Department of Infrastructure has started consulting on plans to mandate AEB, likely in mid-2022. Moving on to the next slide. I did mention that the average age of the vehicle fleet is about 10 years, and that means that is about 20 years, and that does mean that you're only going to get a majority of vehicles having safety features that have been mandated after 10 years. So any delays that we might experience in introducing life-saving technology are going to have ramifications for not just years, but decades to come. So it's very much on our agenda to try and keep up to date with the advances that are being made in other countries, particularly in Europe. The Commonwealth has an aim to harmonise our ADRs with the European regulations, and we want to see that done as fast as possible. Moving on to the next slide. Mentioning Europe, they introduce a general safety regulation, which basically provides a map for introducing various life-saving technologies into vehicles in the coming years. So just to provide an overview of some of them. Full width frontal impact. So this is just about improving the crash protection in frontal crashes. That there are already requirements about that, but this is about raising the bar on what's expected in terms of occupant protection there. Pole side impact is something that Australians should be proud of because this is modelled on the ADR that we first introduced, ADR 85. And so this is providing protection in the event of a run-off road crash where a car collides side on with a pole or a tree, and it provides protection there. And another one they're looking at is event data recorders, and this is more aimed at autonomous vehicles. And we'll all touch on some of the challenges around automated driving, but obviously, if there are any events involving automated vehicles, it's very important for us to get to the bottom of it as quickly as possible. So these data recorders will help shine light on any of the events surrounding a crash. Moving on. Other systems that are moving in the direction of automated technology, autonomous braking, AEB, I've mentioned, and that can detect obstructions in the way, and that can include vehicles decelerating in front, pedestrians or cyclists, or vehicles crossing your path. There are various different types of technology out there. And so this is known to be able to prevent a whole range of crashes. So it's very important that we get that technology out. Vulnerable road user detection, this is a big one for trucks and buses. Unfortunately, it's too common when there are incidents involving cyclists or pedestrians around heavy vehicles because there are a lot of blind spots, and these vehicles do interact in urban environments quite frequently. So it's a challenge, and systems to enhance blind spots and respond and warn drivers if there's a pedestrian or cyclist in the way, or even automatically brake, are very important in addressing that kind of system. There are other systems that are being rolled out which are more focused on automated vehicles. So cybersecurity is obviously a critical issue when you're having automated vehicles. It would be a huge issue if there was any kind of cybercrime that happened around that. So that is a key focus in the regulation, and also in providing the right infrastructure for these vehicles to work on. Moving on, there are technologies to help drivers perform better in the road. So these are technologies like monitoring the driver and warning them if there are any signs of drowsiness or distraction. And that can give them a chance to decide if they need to pull over and take a break or change drivers or whatever to improve their behavior. Lane keep assist when a vehicle starts to veer off their road. These technologies can first warn, and then actually they can move the vehicle back within their lane. So this will help avoid situations where the driver might be inattentive or might have misjudged a curve in the road, to prevent those kinds of crashes. Intelligent speed assistance is a system that uses a combination of reading road signs and also GPS mapping to monitor the speed limit in that environment and provide an alert to the driver if they're exceeding that speed limit. That's quite an advancement on the old days where you could just pre-program a speed limit, which was not a very adaptable system for everyone. Then there's reversing cameras and sensors. So a common or two common tragic occurrence would be situations in driveways with people reversing. There is a situation that you don't have a clear field of view behind the vehicle. So it's very important to provide cameras and even sensors in autonomous braking so that drivers can see and respond to any hazards that might be behind the vehicle when they're reversing. Another system that Europe's rolling out is just a standardized interface for alcohol interlocks. That doesn't mean everyone is going to be required to have an interlock. It's more about when there are drivers that are offenders or for any other reason might be at risk, this makes it simple and more affordable to require interlocks on them. Moving on. Looking further down the track, there are even more advances that Europe's looking at. So improving pedestrian crashworthiness by improving the head protection area, which will address both cyclists and pedestrians. There's also more advanced autonomous braking systems. So this will be able to detect cyclists and prevent drivers that might be changing lanes or veering and not notice the cyclist to prevent that kind of collision. And more advanced driver recognition that could have a more aggressive response if the driver is being too inattentive, or even increase the sensitivity of other driver assistance, such as stability control or lane keep assist, to ensure that that driver doesn't cause any danger to other road users. And I mentioned before that there are issues with heavy vehicles around pedestrians and cyclists. So while you might have systems in place to help avoid that, nothing really beats the driver themselves having a clear line of sight. So another is better design of heavy vehicles to improve their field of view and ensure that they can have as much perception of any vulnerable road users that might be around them. Moving on, I'll talk about the kind of timetable for implementation. Some of this is being advanced more by the regulations coming out of Europe, and others are being advanced by ANCAP. In fact, ANCAP is obviously leading the way in all of this, because what they can do is prove this technology and encourage market buy-in, and only then regulation really comes in. So this is just a list of the various states of where things are going. As you can see, Europe has a much more ambitious timeline than commitments that have been made in Australia yet. We will have flow-on benefits, because obviously a lot of our vehicles do come from Europe, and other countries also are advancing their vehicle safety. But we would like to see as many of those gaps be closed to prevent those poor performing vehicles from entering our country and then remaining in our fleet for years and decades to come. Moving on. So New South Wales has done some mapping to help us plan the actions that we need to take in the years to come to achieve zero fatal and serious injuries by 2056. And we've done lots of modeling, not just based on vehicle safety, but improved road design and driver behavior, and mapping out just some of the few interventions from Europe, which are listed there. We've already identified that by 2030, if all of these were in vehicles from 2023, we'd be saving 90 lives in New South Wales alone, which could be up to 300 across Australia, because New South Wales does account for about 30% of the road deaths. And to emphasize, this is just from mandating these features, because the baseline already accounts for the other market forces that could be influencing safer vehicle behavior. Okay, moving on. Yeah, you can keep clicking to demonstrate this graph. So that presents the baseline, the blue, sorry, one back. The blue line is the baseline of the improvements to safety to 2030, just from an business as usual kind of approach. And as you can see, many lives will be saved, but the bottom line indicates if we do a little bit more, we can already save 90 more lives in the next decade. Okay, moving on. The last thing I want to touch on is some of the challenges around automated vehicles. This is something that's going to be emerging in the years to come, and a lot of people have the perception that these vehicles are going to solve all the issues around human behavior, but that's unfortunately not the case. This is a graph that came from the Insurance Institute of Highway Safety recently, and it shows that really, when it comes to human fallibility, automated vehicles are going to make similar mistakes in about 60% of the cases, and only really avoid 30% of these crashes. So things like misjudging the intentions of other drivers will still present a challenge, and we need to accept that that is not a cure for all problems. And of course, it presents other challenges as well, like the conflict between human drivers interfacing with machine drivers, which could lead to rear ends or other crashes where the responses aren't quite as would be expected. So moving on. And the other challenge as we move to more automated vehicles is that some people have the expectation that they're here now, and that's not helped by a lot of the automated technologies that are driver assist technologies in some of these vehicles that have names that could be misleading, like autopilot or co-pilot, that suggests that the vehicle can do a whole lot more than it can, which leads to crashes like this, where the driver was actually playing a video game at the time, and the vehicle kind of misread the road, which just brings me to the last point, which is that as these vehicles come out, it is also important to ensure that the roads are readable to these vehicles, which is a matter of road design and also maintenance of the road to ensure that there's no markings which a human might understand, but a computer could misread. Okay, thank you. I'll hand you back to Anna.
Wonderful. Thanks so much, David. That was a really interesting presentation. I know for myself that I've had a couple of questions burning in the back of my mind for the last couple of weeks that were answered by that presentation. Thank you. I'm going to hand over now to our ANCAP presenters, starting with Mark, and then Mark will in due course hand over to James. Take it away, please, Mark.
Great. Thanks, Anna, and thanks everybody for joining in. I'll try and present a reasonably quick summary of some of the things that we're doing at ANCAP at the moment, and a little bit about where we're headed in the next couple of years. And then James is going to talk in some more detail about some of the work we're doing in relation to automated vehicles and driver assist technologies. So just there's some very quick background, and most of the people who are online probably know this, but ANCAP's a not-for-profit, member-based organisation. So we use both the resources of the Secretariat and our members to rate a wide range of vehicles. We do that in partnership with international organisations, and particularly in partnership with Euro NCAP. If we could just move on, perhaps to 2 slides on. So since 2018, we've aligned, almost entirely aligned our protocols with Euro NCAP. That gives a couple of advantages. The biggest one is we can share ratings, so we continue to be able to use a large number of ratings for vehicles that come from the European market, and that also has a knock-on effect of pushing forward technologies that are beyond what we would otherwise potentially be seeing in the Australian and New Zealand market. Part of that, we also participate in the Euro NCAP working groups, and that's a two-way flow, I guess, but particularly it gives us visibility of what's around the corner, and some input to ensure that what's around the corner is compatible with what we're seeing in Australia and New Zealand. Through that also we have protocol updates, and since we've aligned, really the time cycle is typically with updates to protocols every 2 years. And I'll mention that a little bit more further on. If we just then go to the next slide. So what this slide shows is how our ratings are made up, and it's quite a complex process. There's actually a lot of tests. So from the old days where ANCAP started with 1 crash test and then moved to additional tests and so on, now we really do have a wide range of assessment. It's really about a broad range of safety technologies, not just looking after the driver, not just looking after the occupants of the vehicle, but also looking after people in other vehicles and other road users, and also, in fact, now moving on to looking after things like first responders and people that are actually rescuing people from cars. So it does go well beyond the what people would traditionally know us for. So since 2018, we've aligned with Euro NCAP with the 4 pillars of assessment. So probably the first pillar is what people would see as being the traditional work that ANCAP's been doing with adult occupant protection. Then we add in child occupant protection, which is a logical extension, really looking mostly at the back seat of the car. Vulnerable road users have been in the mix for a while with pedestrian impact testing, head impacts and upper and lower leg impacts, but also in that column, we then add in pedestrian and now cyclist autonomous braking, and with that as well, looking not only forwards moving, but now since the start of last year, looking at back over as well, where it's available. The last column is probably the one which is in some ways has the most new things in it, and it captures what we call safety assist, but that really captures the crash avoidance and the active safety elements. Some are also in vulnerable road user, but things such as car-to-car AEB, lane keep assist, lane departure warning, and also the speed assistance system, which David mentioned earlier on. All these assessments go together to make up the rating, but the important thing is a vehicle has to do well in all 4 columns to be able to get a 5-star rating. So you need a mix of the technology. You can't just focus on one area and say, well, we've done that and now the car's safe. And that's really the message, is that it is a mixture of all these things. If we can move on to the next slide. This is just a bit more detail about the tests that we do, and particularly those that are new. So people have probably seen a fair bit of sort of examples of footage of ANCAP tests over the years. I mentioned the 2-year protocol updates, and for 2020 we had a big change. So there's a big change at 2018 and a big change at 2020. So this slide just focuses in on those new ones for 2020. And there's some pretty big news in a couple of these things. The first one on the top left is the mobile progressive deformable barrier, and that's a test. There's a couple of things in that test that have been in development since 2000, so it's a 20-year process to get to that. We have the car hitting a moving trolley, which better represents the dynamics of a real crash. We have a bigger deformable element, and that deformable element is able to capture what we call vehicle compatibility information. So not only how good is my car at protecting me, but what's it going to do to the other car? So there's a couple of metrics in that test that actually, where we start to get into looking after other vehicles. It also takes into account for the first time really in the frontal crash scenario, the mass of the vehicle. So you see a difference in the response that a manufacturer has to put into their car from a small car to a big car, because the way they behave in crashes is quite different. There's some more minor changes to the side impact test to increase the severity, particularly increase in speed. The other really new thing is far side protection. So 40% of side impact injuries and deaths have been in far side crashes where the occupant's on the other side of the car from the impact. And this is the first time that we're really, not just for ANCAP, but there's really no regulations anywhere in the world that address far side impact other than just padding in the occupant cell. So that's a big change. It uses some sled tests that the manufacturers provide, as well as we have, and one of the countermeasures is a center airbag that can provide protection between interaction between the occupants. So a person hitting their head on the other occupant, which does happen and is very severe. The other things on this table are mostly extensions of things that we already did. For instance, AEB, we're already testing AEB, but we've added in the back over. The junction scenarios are new as well, and it's fairly early days for junction. Driver monitoring is the first step at looking at the driver fatigue really, and for the first 3 years, indirectly monitoring. So what are my steering inputs? You can, in many cases, tell if a person is wandering from their lane a lot, the chances are that they're fatigued or otherwise impaired, and the car is able to detect that and warn the driver and potentially take evasive action or some kind of additional action. The last one, the box on the bottom right, is also very important, and it's another thing which is completely new for ANCAP, which is rescue, extrication, and safety, and particularly that introduces an ISO standard rescue card that if the manufacturer wants to get the points in this box, they provide a standardized card, and that can be then provided to first responders that captures information about getting people out of crashed cars. And this is particularly with new fuel vehicles, battery electric vehicles, and even hydrogen vehicles, where really there's a lot of extra information that's needed to safely extract someone in the event of a crash. So all of these things add together, and they all go into our rating, and this is part of the march of progress that ANCAP and our colleagues at Euro ANCAP are pushing along. If we just click on to the next slide, this gives us an idea of the timeline of the changes that have been made. So we're sitting here in 2021. So as you can see, we'd be able to see there's a lot of new things that I've just mentioned were added for 2020. And then there's another set of changes that in some ways not as big, but in other ways they're quite huge, that were due for introduction in 2022. With our Euro ANCAP colleagues, we've because of COVID, that's been pushed back a year. So now looking 2023. There's quite a few reasons for that delay. It's unfortunate that it was necessary, but it is necessary. And so I guess some of the big news for 2023, probably that the headline item would probably be motorcycles. So adding a motorcycle as a vulnerable road user in some of the crash avoidance scenarios, both for autonomous braking, but also lane support. So having those situations, for instance, where a motorcycle is in the blind spot and so on, and avoiding crashes in that respect. That's a big thing, and there's been a lot of work done by some of our European counterparts to prepare for that. Another headline item is child presence detection. Again, initially indirectly, and then direct detection of a child. So the child left in the vehicle, usually a parked vehicle, which is not a common occurrence, but a very, very serious one. And the other fairly interesting one is there's a new subsystem for the pedestrian testing, replacing the lower leg with a lower leg that has an upper body mass. So which is a bit more representative of what's really happening when a human being is hit by a car. And it massively increases the amount of energy that is in that impact, and is quite a spectacular test. So and gives some additional challenges to the vehicle designer. So clicking on, we've just got a couple of examples of some of the testing that we are doing now. This we can see, this is an AEB car-to-car test. This is done with the target, I'll call it the target car, which is the soft car on the left, both stationary, moving and braking, and also with a range of overlaps, so representing the normal accident scenarios. And what we see over time is that in responding to those different situations, as the sensing technologies improve, it improves the number of cases where a car can reliably brake and avoid a crash, because what the designer has to do is not only see a car and respond to it, but they also need to not respond in a non-accident situation. So to do that reliably requires an increasing level of sensor development. So over time, and that's what our new scenarios really bring in. If we look at the next slide, the next slide gives a pedestrian. Again, the pedestrian, obviously, it's a fairly classic crash situation. With this, the pedestrian scenarios involve both crossing the road and walking along the road, adult and child, and also daytime and nighttime. So there's a range of different scenarios, and then those are conducted for a range of different speeds as well. So capturing quite a wide range of different pedestrian impact scenarios. And then the next slide will show us the cyclist. So the cyclist was new for 2018. And then some additional scenarios were added in 2020. So this one you can see with the cyclist crossing the road. That is a soft target. Again, you can actually hit that bicycle without too much damage to the impacting vehicle, though you do try and avoid the scenarios where with high-speed hits, because it's both spectacular but also can do a fair bit of damage, and the bicycle is probably costs more than a Tour de France bicycle, so it's a pretty expensive exercise. So that shows that scenario. And finally, the last picture just shows us a bit of a view of the test track. So David already mentioned the Kidal facility. So we actually are very fortunate that through ANCAP we've supported in fact two safety assessed test facilities in Australia, which is fantastic. The Kidal one was the first one, and we have another one in Victoria that's coming online at the moment to be able to support our testing, and both are fantastic, and it's a very big investment to be able to do this. This shows the track, including the junction, which is used for the new junction scenarios. I'll give a little bit more detail in a moment. But also shows the layout. You can see the different lane markings, the crossing, and we use all of those things. So it requires quite a lot of space to be able to test these things and test them safely. Skip to just the next page. Just gives a quick example of how the different trajectories and things are laid out, and how these are defined. That's the pedestrian. So it's a pedestrian junction scenario. So when you turn and there's somebody crossing the road just after you turned, that's a very difficult sensing. There's not many cars at the moment that can successfully avoid this crash, but over time it involves having wider range of view on camera and radar, so that the car can reliably react to that situation. Moving on again, we might just quickly thumb through a couple of these examples. So this, I mentioned the AEB car to car, and this just shows the different overlaps. And then the next slide just gives us the car to car junction. So what people probably don't quite get at the moment, the scenario that we're currently testing is where the VUT, which is the vehicle under test, which is the car on the left, is turning across the path of an oncoming car. So the GVT is the soft car. It's going straight ahead and we're turning across in front of it. And if the system works, our car will prevent us from crossing into the path of that car. Again, that's a pretty complex sensing system. There are cars that can do this at some speeds. Not many yet that can do it at all of the test speeds, but that's where we're headed. So overall, I know it's a quick step through of what we're doing. I think if there are questions about this or people are interested in more detail, they're welcome to talk to us. And if there's particular areas of interest, then there may be an opportunity to delve deeper on another day. But now it's time for me to hand over to James, and he's going to talk a bit about some of the other things that we're up to.
Okay, great. Thanks, Mark. You click through the next slide, please, Susie. So what I'm going to talk about is our proposed assisted driving program. Next slide, please. In 2020, Euro NCAP undertook an assisted driving program. So they developed dedicated test and assessment protocols, and this diagram looks complex, but when you break it down, it is quite simple. The top part of it is showing that part of it is the balance between the driver engagement and the vehicle assistance. So it's keeping the driver engaged in the driving task and what the vehicle systems can do. And then also there is a safety backup, what happens when with an unresponsive driver. The Euro NCAP tested 10 vehicles using highway assist systems, which is essentially adaptive cruise control and lane centering. With these two systems working together, it really is a SAE level 2 system. So next slide, please, Susie, and this will be a short video that Euro NCAP will use the Euro NCAP video to describe what they've done. Is it going to work? to the slides. Go to the next slide. So I've just had a few more words on the safety backup. Go to the next slide, please. So there's 3 levels in the safety backup. It's the ability of the vehicle to avoid the collision, what happens when the system fails. There'll be component failure, or there'll be weather where the system won't work correctly. And then ultimately the unresponsive driver intervention. If the driver's not responding and not getting re-engaged, the vehicle system must be able to bring the vehicle to a controlled stop, ideally on a hard shoulder, and maintaining both lateral and longitudinal control. If we move to the next slide, please. Just shows quickly the scoring and grading. Essentially, you need good scores in both assistance, competence, and safety backup to get a very good score. Next slide, please, Susie. And in 2021, NCAP proposed to undertake a similar program. We're in the process of developing the program. The intention is to develop expertise at NCAP, at our test facilities, and within the local industry. We wish to have a program that covers a number of local volume selling cars, so we can provide good consumer information and also information to policymakers to understand what the current state of the art technology is and what is coming down in new technology in vehicles. Importantly, one of the things we'll also be doing is validating the ability of both our active test facilities to undertake these tests, because we see in the future that it's likely that we will include similar tests in our future test protocols. If we go to the next slide, please, Susie. It's and the next one. So this is the diagram Mark showed earlier, and focused on the new protocols coming in 2023 and then again in 2025. And the couple of additional points I'd make here is that we'll have additional AEB and additional active safety assisted driving type testing, including, if you see the last couple down the bottom, in V2X, and perhaps even looking at connected vehicle testing in the future. Next slide, please. And in what's also happening, and this links a bit into what I think David mentioned earlier, there's a number of United Nations regulations that have been developed for automated driving. So there's an automated lane keeping system regulation, which is essentially an SAE level 3 system. Now, importantly, this has a number of limitations. It's for a low-speed operation up to 60 kilometres an hour, to be activated by the driver only under certain conditions. That'd be on a road with no pedestrians or cyclists allowed, and there's physical separation of traffic. Yeah, and then there's the cybersecurity UN Reg 155 and software safety updates during 156. So they're important building blocks for automated and connected vehicle systems. And in the EU, as part of the EU General Safety Regulation, the driver drowsiness and attention warning standards being developed to assess the driver's alertness through the vehicle system analysis and warn the driver if needed, so to keep the driver engaged in the driving task. And also, now I understand all 4 of these regulations are being considered by the federal government to be part of the next Road Safety Action Plan, and to be introduced into Australia as part of the building blocks or regulatory part of the process for automated vehicle systems. If we go to the next slide, please. I'm just conscious of time, so trying to go a little bit quickly. So with successful implementation, as we've already mentioned, important is the roadside infrastructure, the physical infrastructure, the lines and signs. The NCAP's testing has shown that the importance of both lines and signs for automated vehicle systems. And the connected vehicle, there's some vehicles being delivered in the US and EU with essentially vehicle-to-vehicle systems. And that's really important on the vehicle technology. It relies upon the vehicle technology. But when you go beyond the vehicle-to-vehicle and vehicle-to-infrastructure and vehicle-to-everything else, it's really going to rely upon digital infrastructure. So the next slide, please. I think that sort of brings us quickly to the end. We've had a bit of talk about what NCAP is, who we are. Mark's covered off our testing and rating activities and active safety systems underway. Wanted to outline briefly our plans to undertake an assisted driving program to promote and encourage the introduction of automated driving systems, provide consumer information. And importantly, one thing I didn't mention earlier is one of the things we need to do is to actually highlight or advise consumers of the limitations and the capabilities of the system. So they're not a fully automated self-driving system. They still are systems that assist the driver or only operate under certain conditions. And of course, I think infrastructure is important for both the current automated vehicle systems and where we go in the future. So it's going to be a long time before we don't need good road infrastructure. That brings us to the end of our talks, Anna, so I'll hand back to you.
Wonderful. Thanks so much, James and Mark, for really interesting, comprehensive presentation there, looking both at what's happening now and also looking into the future of what's going on. So we have had a few questions come through. A couple of them I can answer off the top of my head, and some of them I will direct to each of you. So firstly, we had a quick suggestion from one of our listeners who says, can we ensure that we reinforce the use of the word crash as opposed to calling an incident an accident? It's of growing importance as we communicate with the public, and thank you very much for it. Another comment that we had was, can the presenters share their slides after this meeting? It's very useful information. So after the meeting, in a few days' time, everyone who registered for the meeting will be sent a link where they can access a PDF copy of the slides, and also where they can access the recording of the webinar. So that one gets covered. Okay, let me just have a quick look here. As I said to the organisers before, this is always the most challenging part of the presentation for me, is working out which questions and how to get through them. Okay, so one for you, David.
Yep.
Safety technologies for motorcycles seem to be way behind passenger vehicles. And the person asks, what's being done to bring motorcycles up to the same standard as cars? For instance, things like blind spot warnings, lane keep assist, AEB, etc.
Okay. Yeah, look, it's a good question. Definitely, motorcycles present a whole new challenge. They are two-wheeled. The technology behind lane keep assist or AEB for that is more complicated than on vehicles themselves. And obviously they really do not provide a lot of crash protection. So in terms of we need to follow where the technology is. And I don't believe, and maybe James and Mark can provide anything else if they're aware, but I don't believe that the technology is quite ready to be trying to influence that too much in that area. Obviously, we have mandated ABS relatively recently, but again, that was a challenge in itself for motorcycles compared to vehicles. But yeah, as ANCAP pointed out, there are some of these systems that are going out, like AEB, including the lane-changing AEB, and some of the other technologies I've mentioned are going to have benefits in protecting motorcyclists from other vehicles. Yeah.
Okay, wonderful. Thank you. It sounds like, improvements over time. A question for Mark, and somewhat along the same line, similar lines. Europe has had heavy vehicle underarm protection for many years. Is there a timeline for mandating heavy vehicle underarm protection in Australia?
Well, I guess that's probably a little bit outside our area, in that traditionally ANCAP's been dealing with light and close to light vehicles. We have, people may have seen, we did a little bit of work on active safety for larger vans at the end of last year. I guess, and it probably, the challenge with the truck world is that it's so diverse and there's so many different tasks and so many different things. There is some, as people may know, there's some ADR requirements that apply for front underarm protection on trucks, but doesn't pick up sides at this point. That said, I think when we look at how ANCAP has gone about things, going above and beyond regulation, I think we also see in the heavy vehicle space that a number of the users of vehicles have led the way, and where it's feasible, have been able to put underarm protection on the sides of vehicles and on the rear of vehicles, and I think most of them have found that they're able to do so. It doesn't necessarily make the truck any harder to use or any more expensive, but just adds that extra level of protection. So I think there's scope for things to happen outside of the regulatory space as well there.
Okay, another one for you, Mark. When is ANCAP going to introduce a rollover rating like IIHS? So I believe IIHS is the Insurance Institute for Highway Safety.
Yeah, that's an excellent question. And there's a couple of factors to rollover, as people probably know, and David mentioned earlier on. The part of the rollover issue, world can be solved by avoidance, and initially certain electronic stability control offers a significant reduction in rollover and rollover-like crashes, and on top of that, there's also some of the other new safety technologies will help with that. And the obvious one is lane keep assist, lane departure warning, and emergency lane keeping. So avoiding the events that lead to the rollover in the first place. And that's a good thing. I guess the other side to that is it starts to reduce the case for passive safety rollover testing. ANCAP did actually some work quite a number of years ago and before my time, looking at static crash testing, and the challenge with that was essentially almost every vehicle, probably every vehicle that was likely to be tested would have passed easily. So it wasn't looking like it was going to introduce any real change to the fleet, and that wasn't progressed. And I think in that respect, we've managed to focus on, I guess, a good balance of crash avoidance of those crashes where the technologies are likely to work, and passive safety where the technologies are likely to work. So rollover is one of those things that it's a bit harder to solve because there's so many different scenarios and the dynamics between them. You can have a small difference in a crash that leads to a big difference in outcome. So there are not plans currently to introduce a rollover test in passive safety terms. I think, as I mentioned earlier, it's really avoiding the crash is the best answer to that one.
Wonderful, thank you. I noticed that I've been remiss in not keeping a good eye on time, and we've run over by 4 minutes, and a few of our attendees have had to dip out. Very kindly, our panelists have offered to stay on and answer just for a maximum of 10 minutes, any additional questions, and we do have some more that have come through. So any of you who can stay on and join us for that 10 more minutes, wonderful. If you can't, it will be in the recording. And thanks, panelists, for that. Okay, another question for you. I've got quite a few questions for you, Mark. and then one for David and a couple for James too. So, Mark, we have a comment. Jeep recently imported a 3-star car. What can be done to prevent or discourage manufacturers importing substandard vehicles?
I think it's in the essence of what we do, and the reason we're publishing the information about these vehicles is so that people have an idea of the relative performance. But the other thing is we do need to bear in mind that what we are doing is above and beyond the regulatory requirements. And the good news is, and sometimes we cop it a bit for there being so many 5-star cars, and I would suggest that's good news, not bad news. The vast majority of cars that are on the market are 5-star cars and offer advanced safety features, and it's actually quite difficult for the buyer to go out there and buy it's a car that is genuinely unsafe. So the Wrangler that's referring to certainly is a very specialised vehicle. It's in a very specialised market. I think at the time and now we've encouraged that manufacturer and all the manufacturers to make the vehicles, put on as many safety features as they can, irrespective of which market it's in. It shouldn't matter whether it's an off-road vehicle or a passenger car, or if it's an expensive vehicle or a cheap vehicle or a sports car or a people mover. The fact is that safety should be available across the board. But I think, I mean, while it may not sound like great news, the good thing with that vehicle in our market is the manufacturer did respond to ANCAP's ratings and did actually upgrade the car to take it from 1-star to 3, which is at least is a step forward in what was available, and a good example of what ANCAP with the consumers can do.
Okay, thank you for that. So here's another one that's a little bit different. And again, for you, Mark. One of the listeners says, will the driver monitoring test that you mentioned in your talk be done in a driver simulator or on a test track?
Okay, so it's a little bit different to that currently, and one of the things that tends to happen when we have really new worlds of testing and technology is it's quite difficult for the test. The test can't really lead. The test needs to be able to follow what's actually available. So the way it currently works for specifically for driver monitoring is we have what's called a dossier that is put together by the manufacturer to explain what the system they have is, what inputs it takes, how it works, and how it responds. And over time, that can either, we can continue down that approach, or we can introduce perhaps more objective tests. So in that respect, it's really at this point, certainly at what we have now, it would be a manufacturer comes to us and says, we have this system, it looks at steering torque inputs and it looks at lane excursions, and where it sees these changing or where it sees a pattern that indicates fatigue or inattention, then it does these things. So that's where we're at the moment. Going forward, so as we go into the direct monitoring systems, which is really about having systems that actually are looking at the driver, and really we're talking a camera that's looking at the driver awareness and attention. At that point, it has all been developed and built using both simulation and real driving situations, but then taking that and characterizing what you can read from the driver's interaction. So how long is it, how long can a driver blink, or if their eyes are off the road for a period, is this, at what point are you seeing fatigue, rather than just say doing head check or checking the road, or maybe even the sort of short-term HMI things like tuning the radio or dare I say it, answering the phone, or that sort of thing. So that's kind of how it's structured. So it's not so much a on-road laboratory test that you might imagine.
Okay, thank you. A question for David. Oh no, I've got one for James, sorry. Are we still working at SAE level 2, partial autonomous driving, or are there any plans related to ANCAP to move to level 3 in terms of timeline?
Okay, thanks, Anna. Yeah, I start off by saying at NCAP, what we're doing is testing production systems or commercially available vehicles people can go and buy as new. And at the moment, the type of automated systems in vehicles are really the SAE level 2 type systems as described. If it's adaptive cruise control and lane centering, active lane centering is really an SAE level 2. I think with the introduction of the UN regulation for automatic lane keeping, which will be a first entry into an SAE level 3 type system, which is, can be activated by the driver under certain operational conditions, and it really is a low-speed traffic jam assist type system. When we see a few of those coming in, I suspect that NCAP will start, and our colleagues in Euro NCAP will start looking at how we test those and assess those. But there's nothing hard and fast in the timeline yet. It's sort of, we'll be developing our protocols in line with manufacturers developing their vehicle systems and introducing them to the market.
Thanks, James. I have another one for you. Someone says, may I know what you mean by 5 volume sellers?
Oh, okay. It's it's what we want to do to provide consumer information at NCAP. We try to test and rate popular selling vehicles. For example, the ones that are Toyota Corolla, Hilux, Ford Ranger, i30, those types of vehicles is where we focus our attention on, rather than the small numbers, vehicles that sell in small volumes. So what we're saying in our assisted driving program, whilst Euro NCAP tested up to 10 vehicles, the vast majority of those vehicles or variants of those that are available in Australia would be seen as luxury or high price vehicles. What we'd like to do is to test some of the more mainstream vehicles, the ones that sell in higher volumes, the top 20 sellers in the market, for example, a range of those that may have these systems available. So it'll be more relevant to the Australian consumer.
Thanks. Okay, a couple for David, and we're almost out of time. We've only got a couple more minutes. I'll ask one first. The other one we might be able to do by email. One is, sure. Is the policy for 5-star ANCAP rating for the procurement of light commercial vehicles in New South Wales road safety plan currently implemented? Do you want me to read that again?
No, that's fine. Yes, I believe it was published, I think even in 2018, maybe 2019, but I think it was 2018 that it was published. Yes, it's implemented.
And is it currently, it is being implemented? Okay.
Yes.
Another one, and it might be a tricky one for off the top of your head, is could you please provide the reference to the report that suggests 61% of crash problems will not be able to be eliminated with vehicle automation? But we can do that by email if it's tricky.
Look, off the back of my head, I can't, but I would say that it's the Insurance Institute for Highway Safety status report from late last year, I think December last year.
Okay, wonderful. Thank you for that. I'm sure the person who wrote it will let me know if they can't find it, and sure. I will shoot an email. We are out of time. I do have one last question, but I think I'll have to leave that one. Thank you so much, all three of you, for your time and for the really informative, engaging presentations. Such a wealth of information. Fantastic to see. Really appreciate it. Thanks for our audience for staying on, so many of you staying on for the whole thing and joining us. Till the next time. Thanks, Susie.
Thanks, Anna.
Thanks, Anna. Thanks, Susie.
Thank you.